Okay, good afternoon. We are almost done reviewing for the midterm. I'm hoping that your journals are just about finished. Today we're going to talk about sum, difference, half, and double angles, and when we use them and how we use them. Okay, and I know there was always some confusion about half and double angles, about making sure which sign that you're supposed to have on it. So we'll talk about that today too. All right, so let's jump into sum and difference angles. Okay, I'll give you a minute to go ahead and get this copied down. We have two cases to go over for sum and difference. Okay, so case one, you're going to be finding the sine, cosine, or tangent of an angle that's not on your unit circle. You will be told to use the sum or difference formulas, okay? And you will be given two angles, or rather you will have to find two angles on the unit circle that either add or subtract to get the value that you want, okay? So our example is the cosine of 105 degrees, okay? So we can either use the cosine subtraction formula. Remember, cosine's weird and it adds when it's the subtraction formula. Or we can use the cosine addition formula. We just have to find two angles that actually work, either by subtracting to get us 105 degrees or by adding to get us 105 degrees. Okay, and both of those need to be on the unit circle. If we use the cosine subtraction, or rather the cosine addition rather, we could use cosine of 60 and 45, or the two angles 60 and 45, and those would work perfectly fine. If we use the subtraction, and again there's several different ways that you can do this, let's see, what would actually subtract to get us 105 degrees? 150 and 45 would work, and both of those are on the unit circle. The big thing about using subtraction is that you have to make sure you're going in the correct order, right? So that you actually pick your points out in the right way and pick out your exact values. So let's go ahead and do the subtraction formula first. Okay, so we're going to count 150 as x and 45 as y because we're subtracting, x minus y. Okay, so we need the cosine of 150 degrees. Now remember, in your unit circle, okay, where 150 degrees is, it's right here. It's really close to the x-axis, which means it corresponds to 30 degrees, which is also really close to the x-axis. So if you go to 30 degrees on your unit circle, or use your hand, then the cosine of that is root 3 over 2. And in quadrant 2, cosine is negative. Remember, all students take calculus. Okay, so negative root 3 over 2. 3 over 2. Okay. And then you need the cosine of 45 degrees, and that's in quadrant 1, so that shouldn't be that hard. That's just root 2 over 2. All right, and now you need the sine of 150 and the sine of 45. Okay, well, again, 150 over here in quadrant 2, and corresponds to the 30-degree angle as far as its coordinates. And the sine of 30 is 1/2. And so in quadrant 2, sine is still a positive, so that's going to be positive 1/2. Okay, and then the sine of 45 is also going to be root 2 over 2. Okay, so multiply your pairs, do whatever operation, add or subtract, is in the middle. This is going to be negative root 6 over 4. Okay. And this one, this other side is going to be root 2 over 4. And remember that you can write this as one big fraction. So that would be negative root 6 plus 2 all over 4. It also counts, you can flip it around if you don't want to put the negative in the front. You could say that this was root 2 minus root 6 over 4. All three of those would be equivalent statements, and it's fine. You can use either one you like. Okay, and that's if we do this as a subtraction problem. Now, if we choose to do this as an addition problem, okay, so 60 and 45 also work for 105 degrees. Okay, cosine of 60 is in quadrant 1, that's up here. And either, again, using your unit circle or using your hand, the cosine of 60 is 1/2. Okay, so cosine of 60, 1/2. Cosine 45, root 2 over 2. Okay, and then minus in this case. Okay, sine of 60 is root 3 over 2. And sine of 45 is root 2 over 2. And that's why either one would be considered a correct answer, because if you notice, if we do this as an addition problem, what we end up with is root 2 minus root 6 all over 4. So all of those would be correct, and because this is a multiple choice, you need to remember that they're all, not over 2, over 4, that you need to understand that those are all equivalent statements, and you're making the choice, okay? If you're being told to use the sum or difference formula, you get to choose. Are you going to do a sum or are you going to do a difference? You're going to end up with the same answer as long as you use the right coordinates, okay? So it doesn't matter, but again, given an angle that is not on the unit circle, you need to find two that are, that either subtract or add to give you the correct, basically the correct full angle that you're looking for. So that means the exact value, and that word exact is a very specific thing. That's what they mean when they're talking about the coordinates, because I could put this in the calculator and get a decimal, but it's going to be rounded, and that's not going to be an exact answer. Okay, so that is the cosine of 105 degrees. Okay, now that's the easy case, where you're given an angle and all you have to do is pick out two angles that work for it. The harder one, a little bit more solving for this. You're not given an angle that you need to add to. What you're doing is being given two trig functions, and most of the time they're going to be in fraction form, right? Because, you know, sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. It's just automatically a fraction. Okay, you're going to have to do the solving by drawing the triangles that you need, okay? And you need to pay careful attention to where the angles that you're given are, what quadrant they're in, because that'll determine if they're positive or negative. Okay, in this case, you will be told specifically to use an addition or a subtraction, not pick one or the other, and you'll be told which function that you're looking for. Okay, on this one, you're told the function that you're looking for the cosine. Whether you use addition or subtraction is up to you. So this one's a little bit more specific. It will tell you to do addition or subtraction. Okay, so for our example on this one, we're given that the sine of x equals 2/5, and it's in quadrant 2, between 90 and 180 degrees. Okay, so there it is, quadrant 2, and sine being opposite over hypotenuse, that's 2 over 5. Okay, and then we're given that the cosine of y is in quadrant 1 and is equal to 4/5. So there it is, quadrant 1, there's y, and it's 4/5. Now you're going to have to use the Pythagorean theorem to solve for the two remaining sides that you need, right? Because you have to have the cosine and sine of each value to get it to work. Okay, so again, using the Pythagorean theorem, we get something squared plus 2 squared equals 5 squared. Okay, so you'll end up doing 25 minus 4, and we'll just go ahead and leave it as a root. It's root 21. It doesn't simplify. Okay, and then for the other one, the cosine one, this one's a little bit easier. Something squared plus 4 squared equals 5 squared, so 25 minus 16, 9 in this case, which means your missing side is 3. So now all we have to do is remember what our sine addition formula is, and it's pretty much plug and chug at this point. Okay, so our sine addition formula is, all right, so let's see, cos x sine y plus sine x cosine y. Again, you're going to have the formula sheet. Don't stress. So you'll have all those formulas. All you're doing at this point is just plugging everything in fraction form. So looking at x, the cosine of x is root 21 over 5. So we're just going to plug that into the formula. Root 21 over 5. Okay. And go over to the other side. Sine of y is opposite over hypotenuse, so that's 3/5. Okay, no problem. And then back to x, the sine of x, again, opposite over hypotenuse is 2/5. And the cosine of y, adjacent over hypotenuse, is 4/5. So all you're doing is multiplying your pairs once you have them. The hard part is just drawing your triangles and making sure you get your missing pieces. So now we're just going to multiply our pairs and put it together into one big fraction. And that's 3 times root 21 plus 8. And you can't simplify that anymore. So 3 root 21 plus 8. And that's going to be all over 5 times 5, 25. And that is the exact value of adding those two angles together. Okay, so again, a little bit more work because you have to solve for the triangles. Same formula. All you're doing is after that is just plug and chug. Okay, half angles. There are also 2 cases here. So I'll give you a minute. Go ahead and get what you need copied, and we'll go through the 2 cases. Okay, so like the sum and difference ones, you will be told to use the half angle formula. And it's normally going to look something like this, sine of x over 2, or sine of alpha over 2, or theta, or whatever variable is being used, divided by 2. Okay, and that's how they're going to indicate that you're using the half angle formula. Okay, so you're trying to find the exact value of an angle that's not on the unit circle using one that is. Basically taking one that's double the angle you're looking for. Okay, so if you want to find the sine of 22.5, obviously 22.5 is nowhere on the unit circle, and there is no way we can get it by adding, subtracting, or doing anything else like that. So we do know that that 22.5 is half of 45 degrees. Okay, so we need to use 45 degrees for our formula. And remember that all the half-angle formulas are cosine, okay? None of them have sine, none of them have tangent in them. Even if you're finding a half-angle for sine, you're still using the cosine value, okay? Look at your half-angle formulas. They all have cosine in them. Okay, so the value that we need to use is at 45 degrees, since that's what 22.5 is half of. So we need the cosine of 45 degrees, and we're just going to plug it into the formula and solve. And then we'll talk about how we know if this is going to be a plus or a minus. Okay, so right now we'll just put plus or minus. Remember, it's this big root that we're going to have to simplify. And what is the cosine of 45 degrees? Correct, it is root 2 over 2. Okay, so remember that these take a little bit of work to simplify. First off, we have to get a common denominator in the top. And second, we write this thing out horizontally because dealing with double fractions is just gross. It doesn't like the way it looks and it's messy, so we're going to write it out horizontally. So horizontally is going to be 1 minus root 2 over 2 divided by 2. Okay, common denominator over here is going to be 2, right? So this 1 basically gets replaced by 2 over 2. That's what it equals. Okay, so we now have, again, plus or minus, since we don't know what it is yet. That'll be 2 minus root 2 over 2. So now we have a common denominator. And divided by 2. Okay, we talked about when you're dividing with fractions, we don't divide by fractions, we multiply by the reciprocal. So that's going to be, again, 2 minus root 2 over 2 times a half. Okay, almost done. So now we can make this into one fraction that we can simplify. So that's going to be 2 minus root 2 over 4. And remember that if you have the square root of a fraction, you can separate the fraction out, or separate the fraction out as far as take the square root of the top and the square root of the bottom, if it helps you simplify it. And since the square root of 4 does simplify, it's 2, we end up with, remember the double root is okay, we're allowed to have that in this case because it is an exact value that we're looking for. 2 minus, or rather the square root of 2 minus root 2 all over 2. Now, plus or minus is the case, okay? So based on the degree that we are using to put into the formula, okay, 45 degrees is in quadrant 1 and it is positive, so the final output for our answer is positive. Let's say we were doing the cosine of 75 degrees, okay, and we're using specifically a half angle for this, right? Okay, so it's basically half of 150, right? So the half angle, or the cosine that we would use in our formula, is the cosine of 150 degrees. Well, 150 degrees is in quadrant 2, and in quadrant 2, cosine is negative. So your final answer would be a negative, because it's based on the angle that you're having to substitute in. Okay, it's based on placement of the angle. All right, and that is, again, the basic version of half angle. Again, you'll be told, you'll be given the angle that you want to have to get the value of, and so you'll have to double it to figure out what angle coordinate you're going to use to solve it. Okay, and then the little bit longer one, just like with sum and difference, you'll be given a function, and then you'll be told that you're trying to find the half angle of it, and you're going to have to solve using a triangle in the coordinate plane. It's just the way it works. Okay, so for our example, I've given you sine is -3 over 5, and then I'm in quadrant 3. Okay, so there it is, x, and the sine value is -3/5. Now, again, we've already talked about this. Half angles all use cosine. So you have to solve for the cosine of this angle using the Pythagorean theorem, and it is going to be -4. Okay, so if it's -4/5, we're just going to plug it in, and we're going to simplify it, and this one's going to come out to a little bit, I think, nicer than the last one with the double root. So, because this is just going to be 1 plus -4/5 divided by 2. And again, write it out horizontally, get a common denominator. Okay, so write it out horizontally. 1 plus -4/5 or 1 minus 4/5, doesn't matter. Okay, divided by 2, like normal. Get a common denominator, so that 1 should become a 5/5, right, to have a common denominator. And you do need to go ahead and simplify it. So 5 plus -4 is going to be 1, right? So that's now 1/5 divided by 2. Again, we're still inside of a square root. We haven't decided if it's going to be positive or negative yet. So positive or negative. Well, 1/5 times a half, because we don't divide by 2 in this case, would be 1/10. And we do need to split it up, right? Because we can take the square root of 1, and that's just 1/√10. And then hopefully Jalen should be yelling from the side, no roots in the bottom. So that's √10 over 10. So let's figure out if it should be positive or negative. Okay, so where is the angle that we used to find the half angle? It's in quadrant 3. Okay, well, in quadrant 3, cosine is negative, so my answer has to be a negative. Okay, that's how we pretty much determine for half angles. It goes by the angle that you use, that you actually plug into the formula. Okay, so I do have a set of good news for you. There are no double angles on the midterm. Now, we will review, obviously, some more before your final exam. That's in May, and there are double angles on that, but I did not put any double angles on the midterm. And in fact, there's only actually, I think, 2 half angles on the whole midterm. So we're actually done for today. We're going to go over a couple more things tomorrow, and then your midterm is going to be Thursday and Friday. Be good. Have a good afternoon.